The new sensitive radio telescope ASKAP, which observed the satellite galaxy of the Milky Way, a large Magellanic Cloud, detected thousands of new signals from space. All of them are coming from sources previously unknown to us. Scientists have received radio signals for the first time that can help us understand the evolution of galaxies and the origin of stars. But most of these signals are very difficult to decipher, just as difficult as understanding their nature, especially in those cases when such screams suddenly reach us from the depths of space, causing a chill down the spine. Today we know what stars are made of, how a red dwarf differs from a blue one, and what happens after a star dies. But astronomers still do not know exactly how they are formed. And this is despite the fact that about 90% of all matter in the galaxy is concentrated in stars. From this video, you will learn what these ominous sounds are, why scientists were thrilled when they found hydrogen in interstellar space, how champagne is connected to space, and how stars are born. To find out where stars come from, you need to understand what substance they are formed from. In the 1930s, scientists believed that no new stars were being born in the universe. The thing is, hydrogen is needed to form a star, and astronomers of that time could not detect it in space. It turns out that all stars formed almost simultaneously after the Big Bang. And when the last one goes out, the end of the universe will come. But in the 1950s, astronomers discovered that stars differ from our sun and from each other. They have different luminosity, temperature, size, and most importantly, different mass. If from the formation of our sun to its death is about 11 billion years for me, then the lifespan of massive stars is several times shorter. And as we can observe massive stars beyond what we see today, they formed later than the sun. And perhaps they are still forming now. In 1951, 3 independent groups of scientists finally received the coveted signal. With the help of radio telescopes, they managed to detect hydrogen radiation. As it turned out, hydrogen not only exists in interstellar space, there is so much of it that new stars can appear regularly, for example, in such molecular clouds. These clouds consist of hydrogen, helium, a small percentage of heavier elements, and dust. It is inside them that protostars are born. But we cannot see this process. The thing is, hydrogen in space is almost impossible to detect due to its weak radiation. And dust particles in the molecular cloud actively absorb and scatter radiation. It's like trying to see objects in dense fog. That's why scientists couldn't find hydrogen in interstellar space for a long time. But what needs to happen for this element to turn into a star? Scientists do not yet have a precise answer to this question. But there are 2 assumptions as to how this can happen. And the first one is the champagne model. The molecular cloud here plays the role of a bottle. Inside such a bottle, a struggle between 2 forces takes place, compression and expansion. Compression occurs due to the cloud's own gravity and external forces, and expansion due to the gas pressure. Over time, the cloud begins to freeze. It is not heated from the outside, and radiation from the inside dissipates very quickly. When the temperature in the densest part drops to absolute zero, minus 270 degrees Celsius, the gas pressure drops and it begins to compress. How is a star or a star cluster formed? New stars heat up the gas inside the cloud, increasing the pressure, and a stream of gas along with young stars bursts outwards, just like champagne from a bottle. Look at this photograph. The bright area in the center is the cluster of hot gas stars, which broke out from the nebula and are moving through space at a speed of 10 kilometers per second. By the way, this cluster is heading towards the solar system. But don't worry, they won't reach us. The distance from Earth to the constellation of Orion is approximately 4,000 light years. If this hypothesis of star formation is confirmed, scientists may receive a signal similar to this one. The second theory of star formation is related to black holes. In 2017, at an observatory in Chile, a group of scientists observed the collision of two galaxies using a very large telescope. Yes, that's exactly what it's called. The thing is that supermassive black holes in the center of galaxies absorb matter around them. Heat it up and partially eject it outward in the form of powerful gas winds. Scientists have detected radiation from young stars in these winds for the first time. Their age is less than a few million years. In the scale of the universe, they are still children. The supermassive black hole in the gas wind, where young stars were found, is located at a distance of 600,000 light years from us. And where else can we observe the birth of new stars? The Australian telescope ASKAP, which recently sent thousands of new signals to scientists, observed the Large Magellanic Cloud. This is the largest satellite galaxy of the Milky Way, but the main thing is that it is located in the picturesque plane. This means that we can see not its cross-section, but as if observing the galaxy from above. One of the brightest areas of star formation is located in the Large Magellanic Cloud, the Tarantula Nebula. At the center of the nebula is the cluster R136. This is a cluster of young stars, the age of which does not exceed 2 million years. For comparison, the age of our Sun is 4.6 billion years. Perhaps among the thousands of signals recorded by the ASKAP telescope, scientists will find radiation from new stars. But the Tarantula Nebula is located at a distance of 160,000 light-years from us. Can we observe the formation of stars somewhere closer? Let's take a look. This is W51, one of the largest star factories along the entire Milky Way. It is located at a distance of 17,000 light-years from us. This is almost 10 times closer than the Tarantula Nebula. Moving on, the Eagle Nebula, where there is an active star-forming region called the Pillars of Creation. These unusual structures are composed of hydrogen dust, and the dark areas on them are protostars. The Eagle Nebula is even closer, at a distance of only 5,700 light-years from Earth. But that's not the limit. The Orion Nebula is one of the brightest objects in deep space, and at the same time the closest area of star formation to us. It is located at a distance of only 344 light-years from Earth. Can we investigate these areas right now? Theoretically, yes. For example, with the same Australian telescope ASKAP, it consists of 36 antennas, the total area of which is 4,000 square meters. With its help, scientists can see not only stars being born, but also thousands of other cosmic objects. For example, planetary nebulae that remain after the death of stars similar to our Sun. ASKAP telescope is part of the EMO project, the evolutionary map of the universe, which launched in early 2022. Its goal is to allow scientists and us and you to learn more about the evolution of stars and galaxies. Researching different corners of the universe will help us understand how our Sun appeared, and even see what will happen when it dies. In addition to the ASKAP telescope, the EMO project plans to use the SKA antenna array. It is being built with the participation of 20 countries in the territories of Australia and South Africa. This radio telescope will be 50 times more sensitive and will be able to operate 10,000 times faster than any other existing telescopes. Just imagine how many signals we will be able to receive from different corners of the universe. It seems very soon. Instead of fresh releases from Ridley, we will all listen to how new stars appear somewhere in the Orion constellation, or meditate to the sounds of stellar clusters breaking out of molecular clouds. Hopefully, they will be more pleasant than the noise emitted by the nebulous scrub jay. Yes, all this time it was she who was involved in these spontaneous screams. Write in the comments which sounds of a galaxy, star, or nebula you would like to listen to. And don't forget to subscribe to the channel. See you later.